Hey children, welcome back to my video. This is Sir-Nareshh. In the previous video, we have discussed about the image formation due to the spherical mirrors, concave mirror and convex mirror with the help of ray rules. And if you are interested to study the same, I'll leave the video in the cards here. You may kindly go and check. In this video, we are going to study about sign convention and the derivation of mirror formula. Sign convention. What is the sign convention and why do we require it? This is present in both your CBSE as well as your state textbooks also. Why sign convention? Sign convention is actually required in order to study the behavior of the image whenever the object is kept before the mirror. If we dive deep, we have seen that the images formed by a plane mirror are of same size of the object. Whereas for a concave mirror, we have seen diminished image, point sized image, an image which is magnified, images which are inverted, which are erect, these kind of. Whereas if we see a convex mirror, we have seen a diminished and virtual image is being created. So in order to study the behavior of the image when it is kept before the mirrors, mathematically, in order to study the behavior of image whenever the object is kept before the mirrors, mathematically we do require sign convention. We do require sign convention. We do require sign convention. Okay. So before diving deep into the sign convention, let us learn some terms which are actually the distances or the heights. Let us see what are those. Pole, focus, center of curvature. Let us take an example where the object is kept beyond C. Incident ray parallel, reflection passes through focus. Incident through focus, reflects parallel to principal axis. Image is formed between C and F. Image is formed between C and F. Okay. So here the heights which we see is height of the object, height of the image, the distance of the object from the pole, which is said to be as U. Okay. U is the distance of the object from the pole, from this pole. Okay. And V is the distance of the image from the pole. Distance of the image from the pole. And obviously when we discussed about magnification, we have studied height of the object and height of the image. Clear with this, no? Height of the image. So what are the terms involved here? U, which stands for object distance. V, which stands for image distance. HO, which stands for height of object. HI, which stands for height of image. Height of the image. Okay. Now why and how this sign convention is necessary to study this image with respect to the object mathematically. Okay. Now it's so simple. If I consider HO, height of the object, as positive, as the image is inverted, I can take the height of the image as negative. Clear with this, no? Sign convention, giving sign to some value of a variable, not directly to the variable. The variables are UV, HI and HO. We are not giving directly the sign convention to this, but to the values of them. Okay. So in this case, HO, if HO is considered positive, HI is negative. In the same way, whenever the distances, the sign convention even says all the distances must be measured from pole. We will discuss by point to point. When the pole seems to be at origin of the axis, 0, 0. Whichever the distances which are to the left side of the pole, to the left side of the pole, in this direction will become negative, no? Because that will be in the direction of negative x. Okay, and obviously height of the object positive y, height of the image negative y, because if you consider a 2D axis where O is the origin, this is the direction of positive x, this is the direction of negative x, this is the direction of positive y, and this is the direction of negative y. In this way if you consider. So in simple words to say, by discussing the sign convention point to point, what are the simple words we will see. So now the sign convention, okay, sign convention. The first point of sign convention is, see, comparably, I'll take a pole here because the first point of sign convention says all the distances must be measured. All distances must be measured from pole, which is in comparison to the origin of the 2D axis. And this x-axis, I can consider it as which axis? Principal axis. Clear, no? Principal axis. So second point and simple point, I can consider distances which are parallel to principal axis and measured from pole, in the direction of incident ray. See, in the previous case we have seen that u is negative as well as v is also negative, because from the pole they were in opposite direction to incident ray, parallel to principal axis, opposite direction to incident ray and parallel to principal axis. Clear, no? Let me draw an example here to avoid confusion. Pole, focus, center of curvature. I'll take it beyond. See, you can take any case of image formation you can consider, no problem. So this will be the center of curvature. Sorry, image found before the center of curvature and after focus. Now if you see, this is the direction of incident ray and this is the principal axis. Direction of incident ray is towards positive x-axis, whereas these reflected rays are coming towards negative. And where is the object kept? Is it in the direction of incident ray? No, it is in the opposite direction of incident ray. So the second point which we have to consider is distances measured from pole in the direction of incident ray and parallel to principal axis. Okay, from pole parallel to principal axis and in direction of incident ray are positive. Now if you have seen the image formations due to concave and convex mirrors, the last cases of them, sixth case of image formation due to concave mirror and second case of image formation due to convex mirror, you might have seen the virtual image formation where the image has been formed after the mirror. In such cases the image distance would be positive. Clear, no? Okay, in this if you consider, so obviously no positive term because parallel to principal axis and the distances which are in the direction of incident ray and measured from the pole, you have nothing. Clear, no? And the third point, the vice versa of it, distances opposite to, not in the direction, opposite to, from P parallel to principal axis, opposite in direction of incident ray are negative. Okay, from P parallel to principal axis and opposite of incident ray are negative. Okay, so obviously which type of distances can be negative here? This is the object distance, obviously it is negative. Sorry, this is the image distance, this is negative. This is the object distance, this is negative. And let us consider even the heights also, which we'll discuss in 4th and 5th points. So obviously in this case, what are negatives? The values of the variables are negative. So obviously u is negative as well as v is negative. Consider only the values. That means, say for example, this u value is some 20 centimeters. So it must be given as u is equal to minus 20 centimeters. It should not be taken like minus u is equal to 20 centimeters. It can be taken and substituted, but in the derivation of lens formula or a mirror formula, we never consider. If we consider the variables are negative, yes, we have done a mistake. Only the values of the variables must be applied with the sign convention. So you have to take as u is equal to negative, u is equal to some negative value, or u is equal to some positive value, but not positive u is equal to or negative u is equal to in such a way. So the 4th point, distances perpendicular to this principal axis, and above the principal axis. Perpendicular and above are positive. Clear, no? So distances perpendicular to principal axis and above principal axis are positive. Simply to say, along the direction of positive y are positive, along the direction of positive x are positive, along the direction of negative x are negative, along the direction of negative y are negative. Okay, yeah. So obviously here, if you see, this is along positive y, no? So obviously height of the object here will be positive. Okay, so perpendicular to principal axis and below principal axis are negative. How simple is this? So obviously the height of the image will be negative here, the values of them. Clear with this, no? Yeah. So now a deep understanding by sign convention is required. For an erect object, inverted image has been created. For an erect object, inverted image has been created. That is why whenever you consider height of the object as positive, and if you get height of the image is negative stated in the question, then you have to come to a conclusion or think about the cases of image formation where the real image and inverted image is formed. Clear, no? Real and inverted, we have already discussed that real and inverted are pairs. Whenever there is real, it obviously will be inverted for the spherical mirrors. So inverted, so those cases you have to remember. What can be those cases? The first case of image formation due to concave mirror. Second case of image formation where beyond C image is formed between C and F. The third case, on C image is formed at C. Fourth case, object is between C and F and image is formed beyond C. And fifth case, object at focus, image is formed somewhere at the infinity. But the sixth case, the image will be in the same orientation of the object. Obviously HI will be positive there. Clear with this, no? Because it is along with the positive y. Now one wonderful intelligent student will ask a doubt, sir, why can't I keep the object below the principal axis? You can obviously keep. And if you consider there the height of the object as negative, if you get any erect images, they must be taken as positive. And obviously when they are taken on the left side of the pole, okay, object, and if the image is formed even on the left side of the pole, then both the object distances and the image distances will be negative. See, it is not like always we have to take erect images, always we have to keep it like in the left side of the pole only. It is not mandatory. You can take in this way also. In this way also you can take, and that's nothing wrong. Pole. That is why here we have mentioned, what is that? A very important point. In the direction of incident ray. Clear with this, no? And I have found in the CBSE textbook that distances which are always the object must be taken in the left. Actually it is not mandatory, but concerned about the marks, you can mention object is always taken in the left side, and the distance of the object from the pole will be obviously always negative. And image depends. It depends on the case of image formation. Clear with this, no? So this is how simple sign convention is. In order to study the behavior of image, whenever an object is kept before the mirror mathematically. Okay? In simple words, how the image behaves to the object mathematically. That is being said by the sign convention. Clear with this, no? And you can even take other cases also. In my words, if I say all the 5 cases will be almost similar for the concave mirror, because always the object will be on the left side, image also will be on the left side, but image will be always inverted, but the size of it matters. Initially it will be point size, then after that it will keep on increasing its size. And in the last case, where you will find the image is formed behind the concave mirror, there even V also will become positive. Okay, last case if I consider, so if I take an image here, okay, then V will become positive, because in the direction of incident ray parallel to the principal axis, so that V will become positive there in the last case. Even for convex mirror also, always U is negative for every mirror run, whereas V is positive in the 2 cases. What are those 2 cases? No, 3 cases you can consider. What are those 3 cases? The last case of concave image formation, where the image is magnified and virtual. First case of convex mirror, and even the second case of convex mirror, where convex mirror can be used as a rear view mirror. That means it produces the virtual images which are actually diminished and virtual. And in the same orientation. Okay, so sign convention is not sort of nana, but it can be a bit confusing. But let me tell you in simple words, if the object is kept erect and if the image is formed in opposite to it, some minus should be involved. In simple words, some minus should be involved. And whenever if you are taking in the direction of incident ray any distances, they are positive and opposite to them are negative. Clear, no? It's as simple as this. Now let us discuss about the important derivation, which is said to be as the mirror formula derivation. So if you compare with the coordinate axis, in the sign convention, origin, so all the distances generally, even from generally in the 2D axis, every distance will be actually measured from origin only, no? Okay, in simple words to say, this is origin, positive x, negative x, positive and negative y, right? So if any point exists here, say for example 5, point A, so that point will be 5, 0, right? Positive 5, 0. If a point considered as B, here this point will be minus 5, 0. Consider a point C over here, this is 0, 5. D over here, this is 0, minus 5. In the same way, magnitude if you consider all of them are the same, but direction if you consider, B will be negative, D will be negative, C will be positive and A will be positive. In the same way, pole positive, negative, negative. Fine. Now let us derive mirror's formula. Mirror's formula. Mirror's formula. So now let us consider a concave mirror. You can take any case, Nana. I will take a case where object is placed beyond C. You can take between C and F also. That also you will get actually. So I will take beyond C. Incident ray parallel, reflection passes through, focus, incident through focus, reflects parallel to principal axis such that the image is formed between C and F. I'll name this object as AB. Object as AB. Image as A dash B dash. Image as A dash B dash. Now I'll draw some rays onto P because we know, see, all this derivation will depend on similarity of triangles, and that important point we know, all right angle triangles are always similar. Always similar. In such a way, now if you consider in this, the triangle ABP and the triangle A dash B dash P are similar. So B dash P will become hypotenuse, BP will become hypotenuse, AB will become AB and A dash B dash will become the heights of them, and AP and A dash P will become the bases of them. Okay, so simple triangle ABP is similar to triangle A dash B dash and B. By this we know that the ratios of the sides is always equal in the similarity of triangles. In such a way I can take AB by A dash B dash, because here these are the heights now. So AB by A dash B dash is equal to, I'll take the basis. Why should I consider the basis? Because mirror formula, what is mirror formula? 1 by F is equal to 1 by V plus 1 by U. Okay, so I must interfere focal length, image distance and object distance. That's why I have taken this triangle here, these dotted lines, and I have formed some right angle triangles and I have taken them into consideration. What is PA dash actually? It's the image distance. This is the image, no, this is the image distance, V. Okay, and this is the object distance. Okay, so AB by A dash B dash is equal to AP by A dash B. AP by A dash B. Take this as equation number 1. Okay. Now, see, I can even, here you may ask me the doubts, or you can take even the triangle ABF and A dash B dash F also. But in that case, U and V will actually cancel each other. You can try with those triangles also. But we want UV related to F, no? Okay, that's why we'll consider the triangles, another triangle, two triangles which are ABC and A dash B dash C. Okay, again these triangles, triangle ABC is similar to triangle A dash B dash C. Again, let us consider the basis. Basis here are, or we'll consider these heights, no? Heights first. AB by A dash B dash. A dash B dash is equal to AC by A dash C. But if I require this AC, what should I do? If I require this AC, if I clearly see, if this is U and this is R, no? This is R. Clear with this, no? From, we know, radius of curvature is the distance from the pole to the center of curvature. From the pole to the center of curvature. Okay, so if I consider that this is r and this is u, this will obviously become u minus r. Okay, so what is AC? AC u minus r, u minus r. Okay, now if I consider a dash c, I want this. Okay, but this is v and this complete thing, this distance is r, so it will, this value will become r minus v. Clear, no? From this, if this is subtracted, we'll get only this value. So obviously this is r minus v. Consider this as second equation. Now if you consider the first equation and second equation, the LHS are equal, hence RHS will be equal. In such a way, what is AP actually? AP, okay, u by a dash b dash, sorry, that is AB, no? Yeah, so we can write, first let us write the equation to avoid confusion. AP by a dash b dash is equal to u minus r by v, u minus r by r minus v. In such a way, AP, what is AP? AP, u by a dash b, what is a dash b? A dash b, v is equal to u minus r by r minus v. Now I'll cancel this u and v, but still you will have u and v, because in the RHS if we take u and v as common, let us see what will happen. U by v is equal to u into 1 minus r by u by v into r by v minus 1, right? Now if this comes to the LHS, this equation will become, that equation will become u by v into v by u is equal to 1 minus r by u by r by v minus 1. So v cancel, u cancel, 1 into, if I transpose this denominator, it will become the numerator. 1 into r by v minus 1 is equal to 1 minus r by u. Now transposing this r by u to the LHS, so r by v plus r by u is equal to, transposing this minus 1 to the LHS, sorry RHS, 1 plus 1. So what will this become? R into 1 by v plus 1 by u is equal to 2. Now a simple derivation, if this r is transposed to the RHS, what will become? It will become 1 by v plus 1 by u is equal to 2 by r. We know, wicket, we know that r is equal to 2f. Now 1 by v plus 1 by u is equal to 2 by 2f. 2 cancel. 1 by f is equal to 1 by v plus 1 by u. 1 by v plus 1 by u. See how simple is this? Have I substituted any of the sign convention to the variables here? No. We should not substitute any sign convention or apply any sign convention onto the variables. We must apply only the sign convention onto the values. Clear with this, no? Okay. And not only the mirror formula, we do have another formula which is magnification is equal to minus v by u. So these are the two standard equations which you are going to study in the numericals. One is mirror's formula, 1 by f is equal to 1 by v plus 1 by u, and magnification m is equal to minus v by u. Magnification m is equal to minus v by u. So using the sign convention, we'll give the values some sign and substitute them in the formula. 1 by f is equal to 1 by v plus 1 by u, or m is equal to minus v by u. In such a way, we will simply and easily do the numericals involved. How simple is this? That is why sign convention is mandatory. Clear, no? Okay. To prove the behavior of image with respect to the object mathematically, we require some sign convention. Okay. So this is about this video. And if you are up to here and you find this as interesting, you can please subscribe to my channel, share the content with your friends such that they will also learn something. This is Naresh Ramraj signing off for today. Bye bye.